Okay, so picture this. You're sitting at your desk, maybe you get a deadline or maybe you're just bored. You open your laptop, you type a prompt into your favorite AI chatbot. Let's say, I don't know, lasagna recipe, or you're getting it to debug some messy Python code. And in your mind, like hundreds of miles away, a massive industrial faucet just turns on
All right.
and starts blasting fresh, clean water straight into a grain. That is the image, isn't it?
It is. It's a very powerful, very sticky image.
It's everywhere lately. The headlines, the memes. The narrative is that artificial intelligence is, well, thirsty, that it's dangerously wasteful.
That it's literally drinking up our water supply.
Exactly.
Yeah.
And honestly, it feels intuitive. We know computers need power. We know power generates heat. We know heat needs cooling, and usually cooling involves water. It's a logical chain.
It is a logical chain, and that's why it's so hard to shake. But, and this is a pretty significant but, logical chains don't always lead to the right conclusion if the starting premise is skewed.
Right. And that is exactly why we're here. I've got a stack of sources that are honestly a bit mind-bending. We're looking at a core report called AI, Water, and the Economics of Fear, plus some really heavy-hitting supporting texts. And looking at this, the story seems, well, it's not just that the headlines are wrong. It's that they might be distracting us from the actual problem.
That is the crux of it. The mission for this deep dive is to really separate the tool, the AI, from the system it runs on, the infrastructure. We need to figure out if we are looking at a genuine crisis caused by algorithms, or if, as one of our sources puts it, we're just auditioning villains because we're too lazy to audit our system.
Auditioning villains. I love that phrase. It sounds like some bad reality TV show.
Yeah.
But it feels weirdly accurate for how we talk about tech.
It really does.
But before we get to the psychology of it all, let's start with the crime scene, the evidence. Because the core source material admits right off the bat that the claim about AI using water isn't false.
No, it's not false at all. It is just, as the report says, simply incomplete. So let's unpack the what first.
Okay.
The baseline fact is that AI models, your LLMs, your image tools, they operate in data centers. These are physical buildings full of servers. Specifically, servers packed with GPUs.
And GPUs, I mean, they just run so hot.
Oh, incredibly hot.
Yeah.
Much hotter than standard processors, yeah. To keep them from melting down, you need aggressive thermal management. And historically, the most efficient way to do that is through evaporation. You use water.
Right. And we have the documentation, the U.S. Department of Energy, the Uptime Institute. They've all tracked this. They show water usage numbers going up in counties that host these big data centers. So the charge sticks. AI uses water.
It does. But here is the contextual shift that completely changes how you view that fact. This is the first big takeaway from the research. AI did not introduce water usage to computing.
Okay.
It merely increased the visibility of it.
What do you mean by visibility?
Well, think about it. What else runs in a data center? When you're not using ChatGPT, what's happening in those buildings?
I mean, everything. My email, my bank records, the movie I streamed last night.
Exactly.
The government's tax database, my cloud backups, all of it.
Right. Cloud computing, financial systems, healthcare records, streaming platforms, they all rely on the exact same class of facilities. They use the same cooling towers. They consume the same resources. We've been using this infrastructure for 20 years.
That is a really good point. I don't remember seeing headlines 10 years ago screaming, Netflix is drinking our rivers, every time a new season of a show dropped.
But the infrastructure is identical.
Yeah.
It is. The sources really emphasize this. If we're angry at AI for using water, logically we have to be angry at every single digital thing we've done since the broadband era began. We didn't blink when we moved our entire lives to the cloud. But now that there's a new face on the technology AI, suddenly we're looking at the water meter.
So it's not that the water usage is new. It's that the scrutiny is new. We're noticing the bill because a new roommate moved in, even though the rent's been the same for years.
That's a great way to put it. Yeah.
But I have to play devil's advocate here.
Yeah.
Just because we've been ignoring the waste for 2 decades doesn't make it okay.
I don't know.
If I leave the tap running, it doesn't matter if I've been doing it for 10 years or 10 minutes, I should probably turn it off.
Yeah.
How much water are we actually talking about here? Is AI really draining the reservoirs?
This is where scale and perspective become absolutely critical. And this is where the economics of fear report really brings the receipts.
Okay.
If you look at data from UNESCO, the World Resources Institute, and the IEA, you start to see who the real thirsty giants are. And spoiler alert, It's not the chatbots.
So who are the heavy hitters? If we're looking at a pie chart of global water use, who's eating the pie?
Agriculture, industrial manufacturing, energy production, those are the titans. Agriculture alone accounts for something like 70% of global freshwater withdrawals. 70. 70.
7-0. It is massive. And then you have industrial manufacturing and traditional energy production taking another huge chunk.
Okay, so farming and factories, that tracks. But where do data centers fit in that pie chart?
They're a sliver, a crumb. Even with the explosive growth of AI, data centers represent a small fraction of total industrial water use globally. In most regions, it's less than 1% of the non-agricultural use.
Less than 1%. That is significantly less than the headlines would have you believe.
It is.
Okay.
Now, the source is very careful here, and I want to be too. It says explicitly, this does not excuse inefficiency.
Right.
Just because you aren't the biggest waster doesn't mean you get a free pass. If a data center is built in a water-stressed desert community, that 1% matters a whole lot to that specific community.
Geography matters.
Geography absolutely matters.
Yeah.
But on a global scale, the narrative that AI is drinking the planet dry is just, well, mathematically incorrect. And the report points out something else, something really frustrating about where our water actually goes.
Oh. Non-revenue water.
That sounds like some boring corporate speak. What is it?
It's a polite term for leaks. It's water that's treated, pumped, and sent into the municipal grid. But it never reaches a customer because it leaks out of aging pipes before it gets there.
Leaky city pipes.
Exactly. In some parts of the world, even in some U.S. cities, non-revenue water can account for 20 to 30% of the total supply.
Wait, let me get this straight. We're writing angry op-eds because a data center used a fraction of a percent of the water supply while we're losing 30% of our water just because we haven't fixed the pipes under the street.
That is what the author calls selective outrage. And it brings us to the why. If the data clearly shows AI is a small player compared to agriculture and leaky infrastructure, why is the panic so loud?
This is the economics of fear part, right?
It is. The source argues that complex systems do not fit into headlines. Fear does. AI is abstract. It's new. Most people don't really get how a large language model works. That makes it a perfect target. It's mysterious, it's powerful, and it's easy to project our anxieties onto it.
And it's way easier to write a story that says the robot is thirsty than one that says our agricultural irrigation methods haven't been updated since the 1970s and need capital investment.
Exactly. One of the supporting texts has this brilliant line, "Fear is the laziest system of all." It is so much easier to blame a new form of intelligence than to address systemic inefficiencies that require, long-term capital investment. It's lazy.
That brings us back to that quote I loved. If we cared about water, we'd audit systems. Instead, we're auditioning villains. That is such a profound way to put it.
It really is.
It feels satisfying to find a bad guy.
Yeah.
If we can just point at AI and say, you're the problem, then we feel like we've done something. We don't have to look at the leaky pipes in our own city.
It's a distraction mechanism, and it's dangerous because it stops us from solving the actual problem. If you ban AI tomorrow, just unplug every GPU, those data centers don't disappear. The cloud still runs. The water-intensive industries don't vanish.
And the farms keep wasting water.
And the agricultural waste continues. You haven't saved the water. You've just killed the scapegoat.
That is a sobering thought. We could kill the tech and still run out of water.
Yeah.
So let's pivot. We've established the scale is exaggerated and the psychology is a bit suspicious. But I want to dig into the how, because waste is still waste.
Right. We need to get a little technical for a second. We have to separate the code from the pipes. Water is not consumed by algorithms. You can't write a line of Python code that drinks water.
Okay.
The water is consumed by the cooling infrastructure of the facility.
So talk to me about cooling. How does it actually work in these places?
Traditionally, you have what's called an open loop system. You bring fresh water in, it absorbs heat from the servers, and then it goes through a cooling tower where some of it evaporates to release that heat.
And that's where the loss happens, the evaporation.
That, and you also have to flush some of the remaining water out to prevent mineral buildup. That's called blowdown. Exactly, that is consumptive use. But it's not the only way to do it. The industry is moving toward closed-loop systems.
How's that different?
Think of the radiator in your car. You don't have to pour water into your car every morning before you drive to work. The fluid is sealed inside. It absorbs heat from the engine, goes to the radiator, gets cooled by air, and goes back to the engine. It just recirculates.
Well, you fill it once, and that's kind of it.
Ideally, yes. And major operators, Google, Microsoft, Amazon Web Services, they're all shifting toward these closed loops or air-cooled systems specifically to reduce water usage.
So they're aware of the problem.
Oh, very aware. The sources point out that these companies publicly disclose their water usage. They align their reporting with EPA and CDP standards. They are not hiding this. They have public sustainability goals.
So if the technology exists to do this without wasting water, using closed loops or air cooling, why isn't everyone doing it?
Governance. The source really emphasizes this. Water usage is shaped by facility design, by regulations, and by maintenance. Algorithms do not choose these factors. People do. If a data center is using a wasteful open-loop system in a desert, it's because it was designed that way, and the local regulations allowed it to be designed that way. The problem is governance, not intelligence.
That's a really important distinction.
Yeah.
We're blaming the software for the hardware's design flaws.
Precisely.
Okay, so we've debunked the scale, we've looked at the psychology, and we've pinpointed the real mechanical issue as a governance problem. But here's where it gets really interesting for me, the paradox. Because as I was reading, I found this twist I did not expect. The very technology everyone is yelling at for wasting water might actually be the best tool we have to save it.
This is the irony that the fear narrative completely misses. And this is the aha moment. The sources are very clear on this. Research from MIT Technology Review McKinsey. It shows AI is already being used to reduce waste at scale.
Give me some specific examples. How does an algorithm save water?
Let's go back to the biggest consumer, agriculture. Remember that 70% figure? A lot of that is wasteful because traditional irrigation is just dumb. You turn the sprinklers on at 6 a.m. because that's the schedule, regardless of whether the soil is wet, dry, or if it's about to rain.
It's a blunt instrument.
Totally. But AI enables precision agriculture. You use satellite imagery, ground sensors, weather forecasts, and the AI models all that data in real time. It tells the irrigation system, row 4 needs water, but row 5 is fine, and don't water the north field because a storm's hitting in 2 hours.
So it's variable, it's smart.
It's incredibly smart. And think about the math. If AI can make agriculture just 10% more efficient, the amount of water saved there dwarfs the total consumption of every data center on Earth.
Wow, that's a huge leverage point.
Yeah.
We spend a thimble of water to run the server to save a lake of water in the field.
Exactly. And it's not just farming. Remember those leaky city pipes? The non-revenue water?
The 30% law.
AI is incredible at pattern recognition. It's being used right now to analyze acoustic sensors on pipes. It can hear a leak that's underground and invisible weeks or months before a human would notice a sinkhole forming.
So in a way, AI is the plumber we've been waiting for.
It is. The source calls AI an efficiency multiplier. It optimizes cooling systems in the data centers themselves. It forecasts water stress. It helps design better filtration membranes.
But the narrative, the fear, could actually stop this.
That is the danger. The expert notes call this the wedge. Fear-based avoidance discourages the adoption of tools that improve efficiency.
So if we're so scared of the tool that we ban it or heavily restrict it because of this water panic, we're actually preventing the deployment of the very thing that could fix the leak.
Precisely. Fear keeps inefficient systems alive longer. If we reject the smart solution because we've been told it's wasteful, we're stuck with the dumb solution, which is our current leaking infrastructure. We're cutting off our nose to spite our face.
It really puts the headline in a different light. AI uses water? Sounds scary. AI helps fix the water system that has been broken for 50 years is a much better headline, but probably gets fewer clicks.
It definitely gets fewer clicks. But it's the reality. The source talks about how AI didn't invent waste. It exposed it. It's a spotlight. And instead of getting mad at the spotlight for using electricity, we should be looking at what the spotlight is shining on.
I like that. So let's bring this all together. We started this deep dive with a really scary story. AI is a water vampire, sucking the planet dry.
A compelling story, but a misleading one.
Right. And through the sources, we realized that the scale of its water use is actually pretty small compared to farming and industry. We learned that the waste is a plumbing issue, open loops versus closed loops, and that the solution is better engineering, not less intelligence.
And crucially, we learned that the psychology of fear is driving this narrative. We are auditioning villains because it's easier than doing the hard work of governance and infrastructure investment.
And the cherry on top, AI is actually helping us solve the water crisis by optimizing the massive systems that are currently wasting resources.
That's the synthesis, and I think the source sums it up perfectly with this metaphorical punchline. AI is not the villain in the water story. It is the mirror.
It reflects our existing issues back at us.
It does. It reflects our aging infrastructure, our lack of regulation, our historical inefficiencies. And when we look in the mirror and see a mess, our instinct is to smash the mirror.
But smashing the mirror doesn't clean up the room.
Exactly. The source leaves us with a question worth asking, and I think this is what you really need to sit with. The choice isn't whether AI uses water. We know it does. The choice is whether we're willing to invest in fixing our systems, our pipes, our regulations, our cooling towers, or if we'd rather just scapegoat a tool to avoid doing the hard work of structural change.
It's the difference between feeling good and actually doing good. Scapegoating feels good. It feels righteous. Fixing a city's water grid is hard, boring, expensive work. But it's the work that matters.
And as the text says, fear is cheap. Fixing systems is not. Only one moves us forward.
Wow, fear is cheap. That is going to stick with me. It's easy to be afraid. It's hard to be efficient.
And in a world of information overload, critical thinking is about spotting when someone is selling you cheap fear instead of expensive solutions. You have to look at the numbers, the context, and the alternatives.
Well, there you have it. The next time you see a headline about AI drinking the ocean, you can take a breath, pour yourself a glass of tap water, hopefully from a pipe that isn't leaking, and remember, the problem isn't the robot, it's the pipes. And maybe, just maybe, the robot can help us fix them.
If we let it.
If we let it. Thanks for diving in with us today. It's always fascinating to see what happens when you look past the panic.
Always a pleasure.
We'll catch you on the next deep dive. Stay curious.